Some functions call other functions, and recursive functions call themselves. But if we just had a function that called itself, and that was it, we would be stuck in an infinite loop and the code would crash. In order to prevent exceeding the maximum recursion depth, we use what's known as a base case, which tells the function when to stop calling itself and when to start returning values. Every base case has a criteria, and the base case is not called until the criteria is met. In programming languages like Python, you can check this criteria using an if statement. The other case of a recursive function is known as the recursive step. This is the part where the function calls itself. The crucial thing to note here is that during each function call, we use parameters that get us closer to the base case. If we're not getting closer to the base case on each function call, the function will never resolve. In case this is hard to wrap your head around, I'm going to show you exactly what I'm talking about using an example. So, in this blank Python file here, we're going to define a function called factorial, which is going to take in a parameter n and return the factorial of that number. If you don't know what a factorial is, it's the product of all the numbers from 1 to n inclusive. If we wanted to find the factorial of 5, we would need to do 5 times 4 times 3 times 2 times 1. In other words, the factorial of 5 is just 5 multiplied by the factorial of 4, and knowing that is what's going to help us compute factorials recursively. Let's dive a bit deeper into that thought. To find the factorial of 5, we could just multiply 5 by the factorial of 4, and to find the factorial of 4, we could just multiply 4 by the factorial of 3, and we should keep doing this until we reach 1, where we would want this to end. This is how recursion works. All we want to do is multiply n by the factorial of n minus 1. So at the moment, when we call the factorial function, that's calling this line here. But when the program gets to the factorial of n minus 1, it doesn't know what that is. So it calls the factorial function again with this new parameter of n minus 1. And that would look something like this, where the factorial function takes an n minus 1, and thus, to find the factorial of n minus 1, multiplies n minus 1 by the factorial of n minus 1 minus 1, which we can just say is 2. So now when we're calling the factorial function that takes in the parameter of n minus 1, we're multiplying n minus 1 by the factorial of n minus 2. But now we need to compute the factorial of n minus 2. So if we look at the original formula to find the factorial of n, which was n times factorial of n minus 1, we've now got another formula to compute the factorial of n minus 1, which is n minus 1 times factorial of n minus 2. But following that, we need another formula to calculate the factorial of n minus 2. So every time the factorial function is called, it's going to call the factorial function again, decreasing n by 1 each time. But our function is currently incomplete. At the moment, the factorial function is being called again and again and again, and eventually we're just going to be told that we've exceeded the maximum recursion depth, and that's where the base case comes in. As I mentioned earlier, we want to use an if statement to check whether the base case has been reached. In the case of factorials, the base case is 1, so we want to stop calling the factorial function when n is equal to 1, and so we can change our original function as follows. If n is equal to 1, then we call the base case. Otherwise, we just recall the recursive case as we were doing before. And in the base case, when n is equal to 1, we just want to return 1 because the factorial of 1 is 1. At this point, the function starts returning results, working its way back up through every call we've made to the factorial function and solving each one before moving to the next. Currently, our factorial calls look like this. Our original function calls n times the factorial of n minus 1. However, we don't know what the factorial of n minus 1 is, so this original equation becomes n times n minus 1 times the factorial of n minus 2, and so on, and this pattern repeats itself until we reach some value of x such that n minus x is equal to 1. The factorial of 1 calls the base case, and so we know that the factorial of 1 is 1. This step doesn't happen recursively. Now that our program has solved the factorial of 1, it moves on to the second to last function to be called, which would be the factorial of 2, which can be computed by doing 2 times the factorial of 2 minus 1, which is the same as doing 2 multiplied by the factorial of 1, which we know to be 1. Thus, the program can compute the factorial of 2 to be 2. The program keeps doing this until it has solved the factorial of the original value. Let's run through this with some real numbers. Let's say that n is equal to 5, and so when we call our factorial function, we'll be calling the factorial of 5. We know that the factorial of 5 is equal to 5 times the factorial of 4. And we know that the factorial of 4 is equal to 4 times the factorial of 3. And we know that the factorial of 3 is equal to 3 times the factorial of 2 which is equal to 2 times the factorial of 1. And since 1 is the base case, the factorial of 1 is just 1. Since the base case has been computed, we now know that the factorial of 1 is 1, which means that the factorial of 2 is equal to 2. And now that we've solved for the factorial of 2, we can now go back to solve the factorial of 3, which is equal to 6. And now that we know the factorial of 3, we can compute the factorial of 4, which is 24. And finally, the factorial of 5, the original value, can be solved by doing 5 times 24, which is equal to 120. And to check that this Python function is correct, we can call the factorial function where n is equal to 5 and run this in our terminal to get n as 120. If you have any questions or didn't understand something I mentioned in this video, drop it in the comments below and I'll get back to you as soon as possible. If you like this video and want to learn more about computer science, don't forget to subscribe. Have a great day and I'll see you in the next one.